All right, today, you guys, we are going to be looking at reflections. Now, I've already done other videos on translations, dilations, and rotations, but this time we're going to be looking at a reflection. Now, reflection is going to be something that you are very familiar with. You look at a reflection every day in the mirror, hopefully when you are getting dressed or ready for school. Okay, so a reflection is going to be an exact copy of some image, basically. In this case, if you're looking at a mirror, it's going to be that of your face. Okay, so the pre-image is going to be where we start, of course, and the image is going to be where we end up, which in this case, of course, is going to be a little bit different than what you would see in the mirror. So let's look at these triangles. If I'm going to reflect across the x-axis, now, of course, we know our x-axis is here. So if I'm going to reflect from red to blue, I'm going to be making a change to my y coordinate. In this case, I'm going to be multiplying the y coordinate by a -1 or doing the opposite. Okay, same thing. If I'm going to reflect across the y-axis, we have our red triangle here, and I'm reflecting across the y-axis. So in this case, it would become green. And when I'm reflecting across the y-axis, I'm going to multiply my x-coordinate by a -1 or do the opposite of my x. Okay, so again, this is your pre-image, and I have my image here, and I have my pre-image again here, and I have my image there. Okay, and if you notice, we have our prime indicators there. Okay, so let's go ahead and take a look at the algebraic way. As I said here, reflection in your x-axis. This is my rule here. I'm going to be multiplying my y coordinate by a -1. Again, a reflection in my y-axis. My rule states here, x and y will be reflected across the y-axis by multiplying my x-coordinate by a -1. Let's look at this first example where we're reflecting across the x-axis. If you notice, the vertices of the triangle are -1, 1, -1, 3, and 6, 3. Okay, so in the pre-image, which is in red, of course, we have those coordinates. Now, what do I do if I'm going to reflect across the x-axis? I'm going to affect the y-coordinate simply by multiplying -1 by each of the y-coordinates. So if you notice here, we have 1 multiplied by -1 is going to be -1. 3 multiplied by -1, -3. And then, of course, 3 multiplied by -1, again, is going to be -3. So your coordinates for the image are going to be A prime, this coordinate, B prime, this set of coordinates, and then C prime, this set of coordinates. So once I plot each of these, again, as you notice, they are exactly the same, only reflected across the x-axis. What about reflecting across the y-axis? Okay, now, we have a quadrilateral. Now, keep in mind that this can be any image just as long as you affect the rule by each of the vertices. So it doesn't really matter. Okay, so again, it's broken out into a bit of a table here. We have the vertices of quadrilateral P, Q, R, S, which are -2, 5, -1, -1, -4, +2, -4, 4. So what they've done here in this chart is they have simply affected, again, when you're reflecting across the y-axis, they have affected the x-coordinate. So what they've done is they've multiplied, or you've taken the opposite of -2, multiplying that by a -1, because remember, based on the distributive property, we know that there is an imaginary 1 here. So think -1 times -2 is going to give me 2. Okay, so you're not changing anything about the y-coordinate. That does not change. Same thing happens here. -1 times -1, 1. -1 times -4, 4. -1 times -4, 4. One more time. And then once you plot these coordinates, you have your reflected image. So again, this is your pre-image, your reflected image, which again is notated with the prime indicator. Okay, everybody, let's take a look at the way that we would calculate our reflections algebraically. Okay, so remember on this first one, I'm going to use, actually I'm going to use triangles for both of these, okay, just because we are using 3 different points. It makes it a little bit easier for the examples, but remember you can use it for any kind of shape just as long as you have the coordinates of the vertices. All right, so when we are reflecting across the x-axis, remember that the only thing that we're going to do is we're going to affect change on the y-coordinate. So I'm going to take 3, 2, and I'm going to break this down. So I'm going to say, because I'm leaving the x-axis alone, I'm then going to multiply the y-coordinate by a -1. So this was 2, okay? And I'll show you why I'm putting the parentheses in just a moment, okay? So we have, let's see, next, I'm going to leave 4 alone, but I'm going to multiply the next 4 times -1, okay? And I'm putting these in a set of grouping structures for you so you can see it a little bit better. I'm going to leave x alone, and again, I am multiplying -1 times the y-coordinate, okay? So this again becomes 3. When you multiply -1 times 2, that's going to give you what? A -2. When I multiply -1 times 4, that's going to give me a -4. When I multiply -1 times 3, that's going to give me a -3. Now remember, or notice that I am not touching the x value. I'm only affecting change onto the y value. Okay? So now, if we take a look at this, I want to graph it just to go ahead and prove the fact that they will be exactly the same, just in a different position. So I'm going to use 2 different colors here. I'm going to move this down. Okay. So now I'm going to use a coordinate plane that I have constructed. Okay. It's going to be fairly simple. These are in increments of 1. And I do want to go ahead and label these. That's 1, 2, 3, 4, 5, 6, 7, 1, -1, sorry, -2, -3, -4, -5, -6, -7. Okay, so you get the point. Now, because of the fact that this is my own constructed graph, I'm going to use this as a guide, and we're going to count up and use this as the best approximation. I do not have graphing paper available to me. All right. So we're going to use green for the pre-image. So we have 3, 2. So I'm going to count up here as my point. I have 4, 4, right? This is 1, 2, 3, 4 going up. And then I have 1, 3. Okay? So notice here I'm using all of these coordinates. Okay? Now I'm going to connect these as best I can. Okay, so that was a little off, but you think that you get the point. I'm going to just go in just a little bit. Okay, so now I'm going to use the coordinates for my image here. So I'm going to use 3, -2, 4, -4, 1, -3. So I have 3, -2. So again, I'm counting down on my y-axis. I have 4, -4, so that's 1, 2, 3, 4. This is my best approximation, 4, -4. And then we have 1, -3, so that's 1, -3. Okay, and I was supposed to use the different color, so that's what I'm going to use now, sorry. Okay, so now when I connect these, if you notice, it is a reflection of the same shape across the x-axis. Okay, so let's do that exact same thing, only this time we're going to work with the with reflecting across the y. Now, as you guessed, and as I said earlier, when you reflect across the y-axis, you're only going to affect change with the x coordinate. Okay, so it's going to be the opposite of x. Now, I didn't put this note here, but for those of you that are still a bit confused, your pre-image is always going to be your original image. Your new image is the image. So new equals image, original equals pre-image. All right, so now I'm going to do the same sort of grouping structure for you this time. Remember, we are changing just the, we're reflecting across y, we're going to do the opposite of x. So by doing, or by multiplying -1 times a -4, and then leaving my leaving my y coordinate the same, I'm going to multiply -1 times a -2. Remember, I'm only changing the x coordinate, leaving my y the same. And then we have -1 times a -1, leaving my y the same. Okay, so now I want to go ahead and simplify this. So I'm just going to use a regular old parentheses. Okay. Now, -4 times -1 is 4, leaving 2. I'm going to say -1 times a -2, that's 2. And then -1 times a -1, that is 1, 1. Okay, so I'm going to use these exact same coordinates. I'm going to use my constructed graph one more time. I'm going to use both of these points for my pre-image and for my image. I'm going to have this off camera for now. Okay, so the coordinates, I'm going to use my green as my pre-image again. Okay, so I have -4, that's 1, 2, 3, 4. That's -4 and 2, which is approximated to be right there. We have -2 and 4. It's 1, 2, 3, 4. It's going to be approximately there. And then we have a -1 and 1, which is approximated to be there. So now I'm going to connect my dots. And remember, I'm reflecting across the y-axis at this point. I'm going to switch colors. And I'm going to do 4. That's 1, 2, 3, 4. And I'm going to go up to 2 here. Okay. And then I have 2, 4, which is approximately there. And then I have 1, 1. Now, when I connect these, and because of the fact that I don't have graph paper, it may not look perfectly and precisely the same, okay, which is the goal. So if you notice here, these are reflected across my y-axis using those points, okay? Now again, had I had a sheet of graph paper, it would have been perfectly the same, but I'm thinking that you get the idea for demonstration purposes and using the algebraic method of finding those new points. The point is that we have the new points. So if I were to ask on a quiz or a test, what is the y coordinate for, say, point A, B, or C? And let's go back and actually label these. So for the green, I have -4. 2, that was Q. This is R here. This is S, and vice versa. We now have Q prime as, we then have R prime here, and then we have S prime there. The same thing can be said for the other example that I gave. All right. Now, as always, guys, if you guys have any additional questions, you are more than welcome to ask me in class. Come to a tutoring session to get that question answered, or rewind this video for additional assistance. Okay? So, as always, I will see you guys in class tomorrow.